Hello everyone, this slide. These slides are going to take you through exactly what you need to know about rate of change and the types of problems that you can expect to see on the test or on the quiz in the future. So basically, let's get started. The types of problems we're going to be dealing with are projectile motion. So for example, if you throw an object upward, it is subjected to gravity. Usually we're interested in how high the particle reaches and how fast it's going when it impacts the ground. So what does this mean? Things to remember. When an object reaches its maximum height, the velocity of the object will be 0. When an object hits the ground, what is its final position? That will also be 0. These are the two variations on what you can expect to see on these types of problems, either talking about maximum height or talking about when it hits the ground. And so you can see the two different ways that you approach that. So, here's the first question. A rock is thrown vertically upward from the surface of the moon at a velocity of 24 meters per second. It reaches a height given by this formula. You do need to know the formula for projectile motion. And so if you remember that formula, and you should have it written down somewhere, S equals 1/2 gt squared minus the initial velocity times time, plus the initial velocity times time, plus the initial height. So in this formula, 24 is the initial velocity. It would go in this spot. The 0.8 is gravity. So, and this is on the moon in meters per second. So slightly different than what we've been doing in class, but it's the same general idea. Find the rock's velocity and acceleration as a function of time. Remember that if the original function is the position function, then if we're talking about a rate of change, we're talking about a slope, which is the derivative. So the velocity function is going to be the derivative of the position function. So if we use the power rule and take the derivative, that becomes 24 minus 1.6t. And then the acceleration would be the second derivative. So we just take the derivative of the derivative. So the derivative of 24 would be 0. The derivative of negative 1.6t would be negative 1.6. This would be the force of gravity on the moon, negative 1.6 meters per second squared. This would be the velocity, meters per second. Okay, so first derivative is your velocity, second derivative is your acceleration. Now we ask some questions based on that. How long did it take the rock to reach its highest point? Remember that the highest point, the velocity is 0. So we're going to take the derivative, velocity equals 24 minus 1.6t, and we're going to set it equal to 0, and we're going to solve that. So 24 equals 1.6t, so t equals 24 divided by 1.6, which is 15 seconds. So this is the time that it takes to reach the highest point. The follow-up question that's usually asked is, how high did the rock go? To determine that, we go back to our height formula, our position formula. S equals 24t minus 0.8t squared, and we plug in the 15 seconds that we just found. So the height's going to equal 24 times 15 minus 0.8 times 15 squared, which then is going to equal 180 feet. Meters, 180 meters. So this rock would have been thrown up in the air 180 meters, and it would take 15 seconds to get that high. All right, another question is, how long would it take the rock to reach half of its maximum height? Remember from the previous problem that the max height was 180, right, which means half of the height, we're interested in a height of 90. This formula over here, that's the height formula. So 90 equals 24t minus 0.8t squared. And we're going to solve that. So what I'm going to do is I'm going to move the 0.8 over here and move the 24 over here also. So I get 0.8t squared minus 24t plus 90 equals 0. And now I'm going to factor that. Well, I can't factor it, but I'm going to solve it. The only way I can solve it is using the quadratic formula. So if I use the quadratic formula, I'm going to get 24 plus or minus the square root of 24 squared minus 4 times 0.8 times 90, all of that divided by 2 times 0.8. Alright, so if we get our calculator out and we do a little bit of work on it, we get 24 plus or minus the square root of 288. All that divided by 1.6. So we get two answers. P is going to equal 24 plus 288 divided by 1.6, which is 25.6. And we get 24 minus 288 divided by 1.6, which is 4.4 seconds. Alright, notice that we cannot just take half of the time that we found earlier, because that's not going to be enough, because the rock starts off going fast and then slows down and then starts speeding up again. So we can't just say that the max height was 15, half the height would be half of that. It didn't work. Alright, we had to actually solve and plug and go in this way. Alright, so then the next question that I would ask on a test is, how long was the rock aloft? In other words, it started on the ground, it went up, and it came down, and then it hit. So if it started up, and then it came down, how long did it take to do that? Well, if it started on the ground, and it went up, and it came back down, it means it hit the ground over here again. So I'm going to set the height equal to 0. The height formula, remember, is the one that's given to you up top. Right? So if I set that height equal to 0, because the height of the ground is 0, and then I solve that, I'm going to divide everything by 0.8. 0 divided by 0.8 is 0. 24 divided by 0.8 is 30. 0.8 divided by 0.8, of course, is just 1. And then I factor out a t. And then I solve that. I get t equals 0, which is the time it starts. It starts at t equals 0. And t equals 30. Which makes sense. We already figured out that the height up here was 15 seconds. So if it goes up and comes back down, it makes sense that we got 30. But here you can see algebraically the way that that works. And then find the rock's speed when hitting the ground. Speed is velocity. Velocity is the derivative. So the velocity then is going to equal 24 minus 1.6t. So then I would plug the 30 seconds into this. Again, let the calculator do the work, and I get a velocity of negative 24 meters per second. These times up here, of course, were in seconds. And then that would be the velocity of the rock when it hits the earth. So these are the different types of questions that I might ask you on a test, that I will be asking you on a test. And then basically from there on out, you should be good to go. So hopefully this little tutorial helped you, and you can look through it and study and do the different worksheets and be ready for the test. Good luck, and I'll see you in class.